So the next thing we're going to look at is power through any circuit component. So in this circuit here, we've got an ammeter and a voltmeter, and we can put some numbers in. Let's say our ammeter is reading a total of 2 amps, and our voltmeter over here is reading, let's say, 5 volts. And what we want to do is work out how much power is dissipated across our component here. So in this case, you've got a resistor. So how much power is transferred across this resistor? And we can use our very simple equation. Power equals the current multiplied by the voltage. And we've got the current and the voltage through the resistor. Remember, this is a series circuit, so the current at any point in the circuit is the same. So we know the current through the resistor is 2 amps, and we've got the reading for the voltage. So the power then is simply 2 multiplied by 5, and the units for power is 10 watts. Okay, and so we can actually label these. That's power, and that's measured in watts. And if you remember, watts is also the same as 1 joule per second. So you can also use the alternative unit of 1 joule per second. This is your current, as I'm sure you're aware, and that's measured in amps, and this is your potential difference measured in volts. So that is the power equation, and we can actually rearrange this equation to get a different form. So if we didn't have the voltage, we could also use this equation here. Power equals I squared multiplied by R. And if you're wondering where this equation came from, then essentially this is just another application of Ohm's law. Remember, Ohm's law is V equals IR, and what we do is we don't have the voltage, so in this equation we replace V with IR. So in our power equation, P equals IV, we take the V out and replace it with IR. So this multiplied by IR instead, and you should get I squared R. So that's the same thing. Okay, so that's where that comes from. And an application of that would be, instead, if we don't have this voltmeter, let's say we get rid of this voltmeter, and we know the resistance of this resistor, then we know this is 10 ohms and this is 2 amps still. And so we can still use our power equation, but this second form here, we do 2 multiplied by 10, and this should be squared. So 2 squared multiplied by 10, and that should give you 4 times 10 is 40. And again, it's watts or joules per second. Okay, so that's power, and let's have a go at a quick quiz. Okay, so a couple of questions for you to have a go at there, and we want to find the power that is transferred across this resistor and this resistor. Okay, so 2 questions there. Pause the video and have a go. Okay, welcome back. Let's go through the answers. So for question 1 then, it is a simple application once again of the equations that we looked at before. And so we have 10 volts through here. This is a series circuit, so we know that the voltage is going to be split across the components. So if we've got 6 volts here, we know that the remaining 4 volts from our supply voltage has to be over here. So we know that there's 4 volts across this component, and we know that the current through a series circuit is always the same. And so 3 amps is over here. So we know that 3 amps also flows through our resistor. And so now we can use our equation, P equals IV. We've got both the potential difference and the current. So the potential difference was 4. So power equals the current, 3 amps multiplied by 4 volts, and that's equal to 12 watts. Okay, so hopefully everyone got that one correct. Let's look at question 2 then. So here we don't have the voltage given to us. We do have the current and the resistance of our resistor. And so if you want to find out the power across that resistor, then what we can do is we can use the second form of our equation, which we looked at, which is power equals I squared multiplied by R. And we know that I is 4, so 4 squared multiplied by the resistance of 20 ohms. So that's 16 multiplied by 20. And if you put that into your calculator, you should get an answer of 320 watts. Okay, so hopefully everyone got those correct, and I'll see you in the next one.